In this video, I'm going to go through your Unit 3 review, the calculator portion. So our first question says, given the curve x squared equals 2 plus xy, and we're given the derivative. So if I did this derivative implicitly, this would be the result. We want to find all points on the curve where the slope is 3 halves. Well, dy dx is the slope. So we want 2x minus y over x to equal 3 over 2. So I'm going to cross multiply. 4x minus 2y equals 3x. So subtract 3x and add 2y. And we find that x equals 2y. Okay, so anything that satisfies this equation is going to have a slope of 3 halves, but it's going to have to be on this curve. So I'm going to take all my x's and replace it with 2y here. So we're going to have 2y squared plus equals 2 plus 2y times y. So 4y squared equals 2 plus 2y squared. So 2y squared equals 2, which means y squared equals 1, which means y is plus or minus 1. So there are 2 points on this where y is 1. So when my y value is 1, I'm going to plug this back in. My x value is 2. When my y value is negative 1, my x value is negative 2. Okay, we have a function such that f of 2 is 3. This is dy dx. What is the second derivative? So we're going to do this derivative implicitly. So that's going to be 2y dy dx. Plus I'm going to have to do a product here. Okay, and then plus 2x. So we have 2y dy dx plus 1 times y plus dy dx times x plus 2x. Now at this point you can either replace in our dy dx or just evaluate it separately. So we found the second derivative. I'm going to evaluate it at the point 2, 3. dy dx at 2, 3 is going to be 3 squared plus 2 times 3 plus 2 squared. And you have a calculator on this part. So that's 19. So this will be 2 times 3 times 19. Plus y, which is 3, plus 19 times x, which is 2, plus 2 times 2. In our calculator, gives us 159. Okay, so given 2x squared y minus y squared equals 16, show that dy dx is this. AP will do this on a free response question because if you're using the derivative in a subsequent part, so here we're going to be finding the point where the tangent is vertical. If you've done this part incorrectly, they have to, when they're grading it, figure out what the right answer to this would be for your wrong answer up here. So they just give you the right answer and then you do the math so that they don't have to do that. So we'll do this derivative implicitly. So the first part we're going to have to do a product. I need my red pen. 2x squared prime times y plus y prime times 2x squared minus 2y dy dx equals 0. So 4xy plus dy dx times 2x squared minus 2y dy dx equals 0. I'm going to move the 4xy over and factor here. So 2x squared minus 2y dy dx equals negative 4xy. So dy dx equals negative 4xy over 2x squared minus 2y, which is close to this but not quite. I've got to reduce all of my 2's. This will be negative 2xy over x squared minus y. Now we're going to use that to find the points where our tangent line is vertical. That's going to be where the denominator equals 0, okay, which is going to be when y is equal to x squared. So we're going to take that and plug it into our original equation. So we're going to have 2x squared times y, which is x squared, minus y squared, which is x squared equals 16. So 2x to the 4th minus x to the 4th equals 16. So x to the 4th equals 16. The 4th root of that is going to be plus or minus 2. In your calculator, you could do 16 to the 1/4 to get that value if you weren't sure. So I have 2 points. 1 when x is 2, 1 when x is negative 2, and then I'll plug it in here to get our y. So y is equal to x squared, so 2 squared is 4, negative 2 squared is 4. Okay, we're going to find the slope of the curve of this, which is just dy dx. So we'll have 1 plus, we're going to have a product. This will be 4y dy dx equals 0. So 1 plus y plus dy dx times x plus 4y dy dx. So I'm going to factor out dy dx. And subtract 1, subtract y. So dy dx is negative 1 minus y over x plus 4y. For part B, it said find all points on the curve whose x coordinate is 2 and write the equation of a tangent line at each of these points. Okay, so I'm going to plug 2 into this equation. Okay, and solve. So we'll have 2y squared plus 2y, and then if I subtract over that, so we can divide both sides by 2 to get this, and then just factor. You also have your calculator, so you could just graph it and see, where that equals 6 if you wanted. So when y equals negative 2 and when y equals 1, we have our points. So we have the point x coordinates 2, and then we have 2, 1. We want the tangent line for each of these. So we need to find the slope at each of these points using our previous answer. So we're going to have negative 1 minus negative 2 over x plus 4 times negative 2, which gives us a negative 1/6. So this one's tangent line is going to be y plus 2 equals negative 1/6 x minus 2. This one is going to be negative 1 minus 1 over 2 plus 4 times 1, which is going to be negative 2 over 6, or negative 1/3. So my second tangent line is going to be y minus 1 equals negative 1/3 x minus 2. Okay, for number 5, we're going to write the equation of the tangent line when t equals pi for this parametric equation. So we need our point and we need our slope. Okay, from the unit circle, the x value at pi over 6 is root 3 over 2. So this is 1 minus root 3. My y coordinate at pi over 6 is going to be 3 plus 4 sine pi over 6. So 3 plus 4 times 1/2, which will be 5. So that's our point. Our slope, dy dx, is going to be dy dt over dx dt. So the derivative of y is going to be a positive 4 cosine t over the derivative of this one is going to be a positive 2 sine t, since the derivative of cosine is negative. So this is 2 cotangent t, if you wanted to simplify. Now we need the slope. For 6 is going to be 2 cotangent pi over 6. Okay. So cotangent, not cosine. Cotangent is the x value over the y value, which is going to be root 3 over 2 over 1/2. So just root 3. And you can use a unit circle again. So we have y minus 5 equals 2 root 3 x minus 1 minus root 3. The second derivative, we're going to use this cotangent. The second derivative in parametric is d dt of dy dx over dx dt. So for our equation here, we're going to have d dt, dy dx we said was 2 cotangent t over dx dt, which is 2 sine t, and then we just have to take the derivative of cotangent. So that is our second derivative. You could simplify or just leave it like that. Our last problem is going to be very, very calculator heavy, so we want to make sure we know the moves here. Okay, the first thing I'm going to do, I've got 2 equations. I'm going to store them in my calculator. Cosine x squared, and even though they're parametric, I'm just going to use function mode. And then e to the 0.5x. Okay, so in my calculator, this is stored in y1, this is stored in type 2. Okay, is the horizontal movement of the particle to the left or to the right at 2? So that's going to depend on dx. So I want dx dt evaluated at t equals 2, and I'm just using the calculator for that. I could certainly plug it in, but we're going to use our already stored equation to evaluate this for us. So we get a negative 0.654, which is less than 0. So it's going to be moving to the left because dx dt is less than 0. Whenever you're asked to explain, you're going to get a point for that, so make sure not to forget that part. Vertical is going to be dy dt evaluated at t equals 2. So in my calculator, that's y2. y2 evaluated at 2. So 2.718. So is it moving up or down? It's moving up because dy dt is greater than 0. Speed is the square root of dx dt evaluated at t equals 2 squared plus dy dt evaluated at t equals 2 squared. Okay, so you have a couple options here because we did just find those, but I'm going to show you how you can do it all in one step in case you need to in the future. So we're just going to use our shortcut, evaluated at 2 squared plus y2 evaluated at 2 squared. Go ahead and put in parentheses. Okay, and we get 2.7995 or 96. The acceleration vector is going to be the derivative of each at 2. So we're going to do alpha of 2, get our derivative, x of y1 when x is 2. We're going to repeat that. The derivative, x at y2 when x is 2. So we just take those two values and put them in our echelon brackets. Okay, and then the last one is our slope. So slope is dy dx, which is dy dt over dx dt. Again, we've already calculated these, but I'll just do it all in my calculator again just to show you again. So I'm going to have y2 evaluated at 2 divided by y1 evaluated at 2. Okay, which is negative 4.158 or 59. And that's how you use the calculator to do a question like this. That is the calculator portion of your Unit 3 review.